Hi, my name is Lauren Hoffner, and I'm going to be going over the procedure for the alternating current circuits and signal modulation experiment. For the first part of this experiment, two circuits will be made on a solderless breadboard using two different values of resistance and two different values of capacitance. So for the resistance, you can use 1 kilo ohm, 10 kilo ohm, or 100 kilo ohms. And then for capacitance, you can use 10 nanofarads, 100 nanofarads, or 1,000 nanofarads. And for these two circuits, you will observe the voltage across a capacitor versus frequency using the virtual benches oscilloscope or the Tektronix digital oscilloscope. So here is a picture of the two circuits that will be constructed. And you want to make sure that the signal lead of the function generator is hooked up to the resistor and that the general lead of the function generator is hooked up to the capacitor. And then once you measure the voltage versus the frequency, you will calculate the measured time constant and compare those to the calculated time constants that you did for each of the circuits. And then for part 2, you'll be focusing on the frequency dependence of a low-pass filter. You will construct a low-pass filter on the solderless breadboard with the goal of building a circuit that eliminates the AC signal, meaning that across the capacitor, the voltage will be read at a frequency of 10 hertz or less. So the voltage source should be a sine wave at 1,000 hertz frequency, and then you will produce a graph of frequency response of the low pass filter by changing the frequency from very low frequencies to very high frequencies. So 5 hertz to 2,000 hertz of the voltage source, and you would create a Bode plot of the gain versus frequency to calculate the cutoff frequency of the low pass filter. And then for part 3, you will be investigating the ideal sampling frequency. This requires a signal source of a 10 hertz sine wave from the virtual bench function generator and a USB 6002 to collect the signal. And then with the USB 6002, it is important that the wire signal output of the function generator is plugged in directly into the AI0 or AI1 inputs of the USB 6002. And the sampling rate, you will vary the sampling rate using 1,000 hertz, 100 hertz, 20 hertz, and 10 hertz for a few seconds to see which one is the best. And then part 4 involves signal modulation for light detection. So you will build a circuit that has an LED light source, a photodiode detector, and a 2 op-amp amplifier. So in this picture, you could see the op-amp here with the photodiode. And the LED light source is not pictured in this, but the second op-amp will be in series with the output of this op-amp shown in the picture. And then you will test the LED with 5 volts, with a 5 volt 10 hertz square wave, and test the amplifier circuit using the same square wave. If this test does not work, switch the inputs of the op-amp to make a regular inverting amplifier or change the size of the feedback capacitor. But if it does work, you will increase the frequency of the LED voltage until a maximum frequency gives a good output signal. And then you will obtain fruit punch Gatorade flavor and measure the peak to peak change in voltage when you put it in a cuvette and shine light through it. And you will repeat this with 5 dilutions of the Gatorade, and then you will repeat it with water. And then you will calculate the absorbance and make an absorbance versus concentration or dilution factor plot to find the calibration sensitivity of the calorimeter. So this is basically the AC currents and signal modulation experiment. And that was it. Thank you so much.